doesn't remind me again. I think it's Samuel. So please, you can resume your work. Recording, just type or recording. Please don't forget to record. So I said in our last class we did VLAN on one switch. We did VLAN on multiple two switches. And you realize that in that class that only people on the same VLANs can talk to themselves. So today's class is going to be a continuation of that class. Continuation in the sense that sometimes we are not saying people from different VLANs should not talk to themselves. They can talk to themselves. So why are we doing VLAN then? We just want to be able to manage or segment the network. So when you have different people on different segments, if anything is happening, you can pinpoint the problem to that segment. So this is my point now into this class. Because some of the things I talked about in the class is from my own experience as a student. And unfortunately, when I did my Cisco training, the instructors back then did not really know what they were doing. And I don't blame them too. They were a rush to South Africa for instructors training, fast track. They've never had any IT knowledge. So they were struggling too. So you told me that I should do VLAN. I did VLAN. Now down the road, you are saying I should do inter-VLAN routing. Why do I need inter-VLAN routing? What for? But they were not able to answer the question. So these are things that I discovered myself down the road. And so whenever I'm teaching, I try to lay emphasis on some of these things because they were those things were problems for me as a student when I was a student. So why do we do VLAN? We talked about the reason for VLAN is because because of security, we want to isolate traffic. But sometimes the reason why we do VLAN is just because we want to do segmentation. Meaning what? You don't want broadcast from one segment to enter another segment. Let me give you an example again. Let's go back to the router. When we did use a router, if I use a router to segment my network, for instance, now, we did that in CCNA1. If I use router to segment my network, you know that every segment on this router is a broadcast domain. Every segment is a broadcast domain. No broadcast can come from one segment and move to the other. So let's call it, say, LAN A, LAN B, LAN C, and then LAN D. So what did we do with our router? We segmented the network. So this could be accounting, this could be HR, this could be admin, this could be management. It makes no difference. So now what we have on the screen right now, by default, mark my words, guys, by default, people in this LAN A can talk to people in LAN B. When I say talk, I'm talking of unicast traffic now, one-on-one. People in LAN B can talk to C, C can talk to D, everybody can talk to everybody, but there is something that will never pass through. Broadcast will never pass through. Broadcast is not going to ever pass through. If there is a broadcast in LAN A, it will only start and fill LAN A. For the broadcast to cross to LAN B, it's not going to ever happen. That's the reason why we segment the network, because we want to reduce the size of the broadcast domain. So in this scenario right now, security is not the issue for us. It's broadcast that we're trying to deal with. But if we like down the road, we say, you know what? All the people in this LAN A are students. We don't want them to talk to people in LAN B, maybe accounting department. We can create something called access control list, which we are going to come to much more later in this class, not in CCNA2, in CCNA3. We can now go and set up access control list, which is a form of firewall to say, we don't want people in LAN A to talk to people in LAN B. By default, they can talk, but by configuration, they cannot talk. That is when we're now talking about security. So you need to know the difference between these things. So another problem I think I had as a student, I know how to configure this technology, that technology, this technology, that technology. Come and ask me a question about the application in the real world, I'll be looking at you like, yeah, I don't really know what to do. And I know what to do, but I did not know how to apply that knowledge. So when I'm teaching, I try to teach applied knowledge as well in the class. So you need to know what you are trying to achieve. You need to know what you want to do. So follow me carefully into this class. And today's class is not going to be long. So now we were in our last class, we dropped a switch first. We did VLAN, VLAN 10, VLAN 20, VLAN 30. And I told you that there was traffic in VLAN 10, all the traffic, unicast. broadcast, multicast, all the traffic, all forms of traffic will never ever leave one VLAN to another VLAN by default. That's another way. So it therefore means we have isolated the unicast, we have isolated multicast, we've also isolated broadcast in each of the VLANs. What if our intention is not to isolate unicast? We want unicast to move through, but we don't want multicast and broadcast. So meaning we want people in VLAN 10 to talk to people in VLAN 20, people in VLAN 10, 20 to talk to people in VLAN 30, as far as it's unicast communication. But once it comes to multicast or broadcast, it will be isolated in that VLAN, just like what we achieve with the router. So that's not a problem. We can now bring in a router to do the what is called inter-VLAN routing. Then you can now ask yourself the question, so why do I need a switch in the first place? Don't forget what we said. The reason for doing VLAN most of the time is because we do not have enough port on the router to segment our network. Most routers, Cisco routers, you are going to say 4 ports, maybe at most 8 ports. So what do you even have a department of 60 ports? I mean 60 department. I mean an institution of 60 department. How do you segment that network? You got to do VLAN, and you will now use your router to do inter-VLAN routing. And then you're going to see that into this plan. So you need to know why you are doing what you are doing. It's not just about learning how to configure technology. Please, if I'm communicating, let me see your thumbs up. Okay. Thumbs up. Thank you, guys. So it's not just for you to know how to configure technology. You must understand what you are doing. I'm going to give room for questions when I'm done with the configuration. So nobody, you guys know the rule of the class. You cannot ask me a question when I'm teaching. Because if I unmute you now, you're going to see distraction from different angles. So let's get to the business of the day. So in today's class, we want to now do inter-VLAN routing. So what is inter-VLAN routing? We're going to talk about inter-VLAN routing. We're going to implement it on a router, and we will also implement it on a switch. And of course, I'm going to talk briefly about troubleshooting inter-VLAN routing. If there are issues, how do you solve the problem? So you need to be aware of that. So inter-VLAN routing operation. So what is this inter-VLAN routing? Basically, that's what I've just explained to you. When we want people from different VLAN to talk to themselves. You and I know that with what we did in the last class, people from different VLANs cannot talk to themselves. You can only talk to people in your VLAN. So now we want people from different VLANs to talk to themselves. So what is inter-VLAN routing? Look at the definition here. Inter-VLAN routing is the process of forwarding, take note, network traffic. It is the process of forwarding network traffic from one VLAN to another VLAN. That's what we want to achieve in today's class. And you guys can't believe what I'm going to do. The same network we worked with in our last class is what I'm going to use today in today's class. I deliberately said this so that you can see that, okay, we just continue from there. So it is the process of forwarding network traffic from one VLAN to another. We can allow unicast to move. The multicast will not go anywhere. And guess what? Broadcast will not go anywhere. So how do we do that? There are 3 ways to do it. One is old school. Does not even make sense to me in the first place. You're going to see it. So there are 3 inter-VLAN routing options. First option is called legacy inter-VLAN routing. This is a legacy solution. When you hear legacy in IT, it simply means old school. Let me talk the language of the guy's street language. It's old school. And guess what? They say it doesn't scale well. When you hear scale in IT, it simply means you cannot grow. So when we don't even using it in the first place, it never makes sense to me. You're going to see it. We are not going to even do this. We're just going to discuss it. So the second option is a router on a stick. We are going to do this. This is an acceptable solution. Take note, for small to medium size network. What is a small network? What is a medium sized network? When you have a network of 500 users, 1,000 users, 2,000 users. You can refer to them as small. And sometimes these things are relative. But by the time you begin to have a network of 5,000, 7,000, 10,000, that's not a small network again, guys. It's a medium-sized network, especially when you're in campus environment, university. So they said if we find ourselves in a small network, we should use router on a stick solution to do inter-VLAN routing. If you find yourself in a medium-sized network, you can still use router on a stick. But the time will come when you find yourself on a network that is from medium to large, 10,000 users, 15,000 users, 20,000 users, you are not advised to use router on a stick. You are advised to use a layer 3 switch. What is a layer 3 switch? A layer 3 switch is a regular switch, or let me say, not regular switch. A layer 3 switch is just a switch that has higher capability. It can do the job of a router. So why sometimes you hear us call that switch multi-layer switch. Multi-layer. Why is it called multi-layer? It operates at layer 2 and it still operates at layer 3. This switch is not your regular type of switch. It is a switch that can do the job of a router and even do it better than a router. So they are telling you guys, if you find yourself in a medium to large organization, do not use your router on a stick, or don't even use router to do inter-VLAN routing. Use your layer 3 switch. And in today's class, we're going to do the two of them. You see how we implement inter-VLAN routing on a router on a stick or on a router, and how we implement inter-VLAN routing on a layer 3 switch. You must know how to do the two. And they are very simple and straightforward. And I can bet it with you, especially if you're outside the country, you will find yourself in an environment where you have to do VLAN and inter-VLAN routing. It's a technology that is always in use. People use VLAN a lot. VLAN and inter-VLAN. It's a popular technology. I remember teaching one of my private students in the UK, and I said, when I was teaching VLAN, I said this to him. So when we finished the training, he was preparing to write certification. So he told one of his superiors, because he was working as an IT person, IT support, not network engineer. So he told one of the superior that is in networking that he's preparing for his CCNA, and he has done the training. The first question the guy will ask him that, can you configure VLAN? He said he just started laughing because I already told him VLAN is very important, guys. There are some technology you can just decide not to, maybe to ignore them. When I say ignore them, maybe you may not come across their use in the feed, but not VLAN. VLAN is very popular out there. So you got to know VLAN like you know yourself, and you got to know inter-VLAN like you know yourself. So please take note of that. So look at what they talk about in legacy. This legacy will never make sense to me. So look at what they did with legacy VLAN. I'm not going to stress myself reading all of those stuffs there. I have a switch. In fact, I can even draw that on. I have a switch, VLAN 10, like what we did in our last class, VLAN 20, and let's say VLAN 30. And now I want to do inter-VLAN routing on this, between this VLAN. I will get a router and attach 3 different cables to the switch. One cable for VLAN 10 to carry traffic for VLAN 10, one cable to carry traffic for VLAN 30, one cable to carry for VLAN 20, and then VLAN 30. So what does that mean? Whenever you hear us saying we are doing inter-VLAN routing, all we are simply saying is we need a gateway. We need a gateway. What is a gateway? Your router is a gateway that can route traffic, move traffic from one VLAN to another VLAN. So if we attach a router to this switch as we are seeing it on the screen right like this, anybody plug in VLAN 10, we will go and tell that person, give the person his IP address, give the person subnet mask, and give the person a default gateway. Anybody plug in VLAN 20, we give the person IP address, give the person a subnet mask, tell the person about default gateway. Anybody plug in VLAN 30, you have an IP address, you have subnet mask, you have default gateway. It therefore means if you need to get out of your VLAN to go to another VLAN, that traffic will go through the router, and the router will now forward it to VLAN 20. If you need to talk to somebody in VLAN 30, that traffic will go through the router and then now go to VLAN 30. So where this thing does not make sense to me is it, what if I now have 40 VLANs? Or let's say 10, VLAN 40, VLAN 50, VLAN 60. So I will need multiple interfaces, physical connection on this router. The same thing we're running away from on our router. When I say running away from, the reason why we're doing VLAN is because we didn't have enough interfaces. Now we are going to need more plenty interfaces to do inter-VLAN routing. So this is, it makes sense. So if you are in an environment where you have 60 departments, it therefore means you will need 60 different connections from the router to those switches. One connection to carry traffic from one VLAN to another VLAN. So the aim is defeated. This never makes sense to me. The aim is defeated. And look at what they said. They said this method of inter-VLAN routing is no longer implemented. If they were even doing it in the first place, I don't know why, because it didn't make sense to me. And this is just for explanation purposes alone in this class. So how do we do inter-VLAN routing? Today, that's what we want to go to now. So you never ever do inter-VLAN routing the way they were doing it in those days. You will do your inter-VLAN routing in the way they do it nowadays is by using a technology called router on a stick inter-VLAN routing. And watch out now. Watch out, guys. I'm going to read this and I'm going to explain. This is amazing. I like this technology. I like talking about VLAN and inter-VLAN routing. So watch out now. The router on a stick. Why did they call this a router on a stick? I'm coming there. The router on a stick inter-VLAN routing method overcomes the limitation of the legacy inter-VLAN routing method. How? I'm going to explain to you guys. It only requires, take notes, guys, one physical internet interface. Only one port to route traffic between multiple VLANs on the network. So when you say router on a stick, physically you have just one physical connection to the switch. But guess what? Logically, you will have multiple connections to the switch. This is what I'm trying to say. Let's assume, back to our switch. Look at my drawing here. VLAN 10, VLAN 20, VLAN 30. Let's even add one more. Let's say VLAN 40. And I want to do inter-VLAN routing between all of these VLANs. I want to be able to talk from one VLAN to the other. All I need is just one physical connection to my router. Only one. And this one interface, just one physical interface, is all I'm going to use to carry traffic for VLAN 10, carry traffic for VLAN 20, carry traffic for VLAN 30, carry traffic for VLAN 40. Even if I have 50 VLANs, only one physical interface will be used physically. But guess what, guys? Logically, spiritually, we're going to set up spiritual connection or logical connection for each of those VLANs. So even though physically you are seeing one leg connection to the switch or switches, logically there are multiple connections by configuration, and you're going to see that. So we overcome that limitation of ports. One port can grasp for 50 VLANs, even though it's not advisable to go beyond that. Only one port. So that's why this router on a stick is just one leg connection. But logically, you have multiple connections. So if I have 50 departments and I want them to be able to talk to themselves, one router can do that job for me with just one port, physical port. I will now go to the spiritual ports and begin to do my wonders. And you will see how we're going to do that. Let me take this statement again. The router on a stick inter-VLAN routing method overcomes the limitation of legacy inter-VLAN routing method. It requires only one physical Ethernet interface to route traffic between multiple VLANs on the network. You see that? A Cisco iOS router interface is configured. Take notes. This interface here must support trunking because it's going to be carrying VLAN for multiple, traffic for multiple VLANs. Take note again, the interface on this switch must support trunking. We are going to see it at work. Let's finish our explanation. So that interface is connected to a trunk port on a layer 2 switch. Specifically, the router interface is configured using sub interfaces. What are sub interfaces? Those are our logical interfaces. Those are our spiritual interfaces representing different VLAN. So when you get sub interface, those are just logical interfaces. And look at what they call those interfaces. The configured sub interfaces are software-based virtual interfaces. They're not physical ports. All of them will use one physical port. If you like 50 virtual interfaces or logical interface, all of them will use one physical port, and this thing is going to work perfectly. You will see that work. And what now? Each is associated with a single physical Ethernet interface, each of the logical interfaces. Sub interfaces are configured in software on router. It's not a physical thing. Each sub interface is independently configured with an IP address and VLAN assignment. So if I pick a particular sub interface, now I can say you are representing VLAN 10. I'll give it an IP address, give it subnet mask, and I'll tell that interface you are representing VLAN 10. I'll pick another sub interface, let's say sub interface 20. I'll give it an IP address from VLAN 20. I'll give it subnet mask and say you are representing VLAN 20. And you will see this at work. So sub-interfaces are configured for different subnets. Take note, every VLAN is a subnet. After I said that before in this class, corresponding to their VLAN assignment. And this facilitates logical routing. So people cannot talk between different VLANs. When VLAN tag traffics enters the router interface, you remember our VLANs will be tagged. It is forwarded to the VLAN sub-interfaces after a routing decision is made, meaning the router has decided where the message is going to on the destination IP network address. The router determines the exit interface for the traffic. If the exit interface is configured as 802.1 sub interface, the data frame are VLAN tag with the new VLAN and sent back to the physical interface. So this is what we are trying to say now. Let's say this router has a physical connection to this switch, and then it's carrying VLANs for VLAN 10, VLAN 20, VLAN 30. So the message will enter through that physical port. The router will decide, oh, where are you going to? Where are you coming from? You are coming from VLAN 10. Where are you going to? You are going to VLAN 20. It will make decision and push it back through that interface again. So what will now happen? It will change the destination address, work on it and say, okay, you are going to VLAN 20. Send the message to the switch, and when it gets to the switch look at the frame. It is tagged already. It knows this message is going to VLAN 20. Who are the people? Where are the people in VLAN 20? VLAN 20 have been created on this switch. People are in VLAN 20. The switch will drop that message. Check the MAC address in VLAN 20 and see all the people that are connected and their port, and then push the message to whoever is the owner. So the router can facilitate routing between different VLAN, and only one leg is connected to the switch. Only one leg of the router is connected to the switch. And now, the router on a stick method of inter-VLAN routing does not scale well. Look at what it said. Once you have more than 50 VLANs, don't use this solution. Go for the switch. So let's see this work. Let's see this at work. Then after that, I will give room for question. So guys, this is our last lab that we did. Please give me thumbs up if you can see the topology. Thumbs up. Can you see my screen? Okay, good. So we work on this. We work on this in our last class. We work on this together. Thank you guys. I can see your thumbs up. So you can see what we got here. We have accounting department. We have HR department. We have admin. Of course, you remember what we did with our management VLAN. And of course, we have native VLAN. I didn't put native VLAN here. Remember what we did with native VLAN is between the switches. So in today's class, people are in accounting department, they can talk to themselves, but they can't talk to people in HR. They can't talk to people in admin. So what do we want to do in today's lab? We want everybody to be able to talk to themselves. So how do we do that? I will bring out a router and connect to this switch. If I like, I can connect it to the other switch. It makes no difference. I will bring a router and connect to this switch and begin to pick an IP address from my accounting department. I can decide to pick 192.168. Let me say, I'll pick a sub interface first. Let's pick sub interface. I think that should be VLAN 10. It is good that the numbers correspond so you don't make mistake when you're troubleshooting if you have any issue. So I can now go to that interface and pick an IP address. Sorry, that's subnet 192.168.1.1. You guys know that I said don't use .1 because I want to use it on my router. So if I put this IP address on the router, I will now go to the guys in accounting department and say, guys, you know what? There's a good news. You can now travel out of your local area network or your VLAN to another VLAN. I will pick an IP address from VLAN 20, which is our HR, 192.168.2.1, put it on my router, and go to all the guys in that HR department and give them default gateway. If you guys notice, all this while we've been working, we've not touched anything about default gateway. And tell them about default gateway. And I will do the same thing to admin department and say, guys, you know what? I'll pick an IP address from there, 192.168.3.1. I'll put it on the router. Any IP address I put on the router, I'm going to go to the computers that belong to that VLAN, that subnet, and tell them that there's a good news. You can now go to the internet. And by the time we're done with this, people can talk to themselves. That's great. So I'm going to bring in a router. I'm a fan of 2911. I don't know why I don't want to let go of this router. It's old school. It's old router already. And then I'm going to connect this router to my switch. Router to the switch is a straight through cable. Unlike devices, so I'll use gigabit 0/0. Then connect to my gigabit 0/2. You can use any port, guys. Just be aware of any port, the port you want to use. So now I need your attention, guys. I need your attention. You recall that the interface on the routers are shut down by default. So I've talked to you that when we're doing configuration. So I'm going to go to this router, go to command line on this router. Let me increase the font size. So on this router now, guys, so see the interface we are using, show IP interface brief. Look at the interface we are using, G0/0, gigabit 0/0. That interface does not have an IP address. That interface is administratively done. Now, I've told you guys this. Every interface on the router by default is shut down. In fact, not just shut down, it's administratively done. It means we need to activate it. That's why when you're configuring a router, you say no shutdown. So you need to be aware of this. But this is where I'm going. Anytime you want to use the interface of a router to do inter-VLAN routing, that interface must not have an IP address. Because that interface is routing from different VLANs. So you cannot put IP address on that interface. So what I'm going to do right now. I'm going to enter into that interface. I'm sure somebody will say, it's not doing line console 0, line VTY, line this. I've told you that one, we have passed that level. You must have mastered those ones now. In the real world, you do that. So I'm going to enter that interface. And the first thing I'm going to say is no IP address. Why am I doing that? In case there's an IP address on that interface. And then the next thing I will do is no shutdown. Guess what? I'm done. But the first thing I need to do, make sure there is no IP address on that interface. Activate that interface. Take note of this. Anytime you want to use a physical port on your router to do inter-VLAN routing, do not put an IP address on that interface. I repeat, do not put an IP address on the physical interface of your router whenever you are doing inter-VLAN routing. Activate that interface. And that's the first thing we need to do on this router. So what's the next thing I need to do? I'm going to travel now into the logical interfaces. I am going to be traveling into the sub-interfaces. How do I go into the sub-interfaces? Because those are the interfaces we want to use to do inter-VLAN routing. I will go into my interface, global configuration mode, and say interface gigabit, guys, 0/0. The moment you say dot, you're on your way to the spiritual world of this port. Interface gigabit 0/0 dots. I can say .1. I can look at the ports, they are in billions. The ports are plenty. Look at them here. I press question mark. They're in billions. Is it even billions? I think it's in billion. Any of these ports can work as if it's a physical port. Any of them. So best practice. You are advised to pick the sub-interface that correspond to the VLAN that you have created. Not that if you pick any other port, it will not work. It will work. But it's good for you because when you run into trouble, you want to troubleshoot, you know the port you are using. So since I think we have VLAN 10, VLAN 20, and VLAN 30. Let me confirm that on our switch again. Show VLAN brief. You see, accounting guys, I am VLAN 10. HR, VLAN 20. Admin, VLAN 30. So we have 3 VLANs. You guys know that we did all those things together. So since we have VLAN 10, VLAN 20, VLAN 30, it makes sense for me to pick sub-interface 10. And watch out now. By the time I hit enter, look at what my prompt has changed into. My prompt has changed into config sub-if. This is what we call sub-interface. We are in sub-interface 10 now, .10, 0/0.10. This is one logical interface. And you know what? This logical interface can work like a physical interface. So the next question now is this interface, which VLAN? I want to use it for VLAN 10. So what next? I need to give it an IP address from where? From VLAN 10 subnet. That's why you need to understand this. Every VLAN is a subnet. If I'm giving this sub-interface an IP address, I must pick from that subnet. It's okay. So we have decided to pick to reserve .1. So I can say, okay, IP address 192.168.1.1 spacebar 255.255.255.0. I have picked an IP address from VLAN 10 subnet HR, and this IP address is going to be the default gateway. That means exit out of that LAN. So we're going to go and tell our computer it's going to be the default gateway. But you know what, guys? This is not going to work. The router is going to complain. You see what it's going to tell me now. I hit enter. The router said, you know what? Configuring IP routing on a LAN sub-interface is only allowed if that sub-interface is already configured, take note, as part of IEEE 802.10, IEEE 802.1Q, or ISL VLAN. So the router is telling me that, you know what? There is a tagging mechanism that needs to be configured on this interface. There are 3 types. You got to pick one. I don't know which one to use. That's number 1. Number 2, I don't even know the VLAN this sub-interface is going to work for. You got to tell me. So I'm going to tell my router and say, sorry, you are going to be working for, I'll say encapsulation, sorry. Encapsulation.1Q. I think it's 10. Let me see that command. Yes, 10. So what did I just do, guys? I am telling the router, use 802.1Q. That is the tagging method. Encapsulation.1Q. And you know what? You will be routing for guys in VLAN 10. You will be working for people in VLAN 10. All the guys in VLAN 10, they are your responsibility. This sub-interface. Then I will hit enter. can now put an IP address on this interface. If I put out up arrow key right now, that address is rejected from me before. I can now hit enter. Guess what? I'm done with this interface, sub interface. If I put do your history for you, you see what I did on this interface. I enter the physical interface, or let me say on this router. Say no IP address. I say no shutdown. And then went into the world of the logical interface. I put an IP address, it rejected it. And now say, okay, you're going to route for VLAN 10, and you use 802.1q, which is the same thing as .1q. And I put an IP address. And guess what? I am done for people in VLAN 10. So I can now go to the computers that are plugged in VLAN 10 and give them the good news. What is the good news? They have somebody that will help them to travel out of their VLAN, which is our default gateway. And the default gateway is your router. But let's finish others as well. And then we'll now go and tell people the good news. So I can as well go to another sub-interface for VLAN 20. So I can use my up arrow key, guys, and say interface gigabit 0/0.20. Hit enter. This is now a different subnet. A different sub-interface. This interface, I want you to route for people in VLAN 20. So I have to tell that sub-interface, you know what, you are going to be routing for people in VLAN 20. Then I will now indicate up arrow key again to return those commands. Encapsulation .1q 10. I can edit this. This interface is for VLAN 20. I will hit enter. I can use my up arrow key again. Just edit the IP address that I put, because I know that people in VLAN 20 are using 2.1. So I put 2.0 network. So I put 2.1. And guess what? I'm done with that interface. The reason why I'm not using up arrow key, because I don't want to start typing all over again. So you should get used to that. I can do the same thing for the third VLAN. I'll go again and say, you know what? Interface gigabit 0/0 VLAN, sub-interface 30. That means this sub-interface will be working for people in VLAN 30. Then I will tell that interface the VLAN is routing for encapsulation .1q, and then I did it 30. And of course, I'll give that interface sub-interface an IP address. I can use my up arrow key again, bring out the old IP address, then edit it, and then put 3.1. Guess what? I'm done. If I push you run for you right now, you see all the things we have done on this router. Look at what you have done on this router. Because sometimes these things will not work accordingly. You got to go to your show run to see what you did in case you did something wrong. So herefore, you can now see what is in your running configuration. Okay, interface gigabit 0/1.10, sub-interface 10. I told that sub-interface to route for people in VLAN 10, and I give it default an IP address of 192.168.1.1, and this subnet mask, and then the people in the sub-interface 20, and they are routing for VLAN 20. I gave this the IP address, and people in VLAN 30, I gave. So in case you made mistake, you can say from zero on. That's the output of your running configuration. Show running config. We've used that command before. So if I'm sure I've done the right thing, then I can now go to those computers and begin to break the good news to them. I say, guys, it's good news. You can now go to other VLANs. Account can talk to HR. HR can talk to admin. That is the good news in the house right now. If you have done the right thing. That is why I always tell my students, build and verify. Build and verify. Don't just build. Later on, you now want to start testing. No, build and verify. It will save you a lot of headache. So now, as I've done this, I can go to my computers and say, okay, where are the guys in VLAN 10? I'll click this computer, go to desktop, go to IP config. Look at this guy. This one is 192.168.1.2. Look at the subnet mask. On that gateway, you see, we didn't put anything. Now, there is good news. Who is our default gateway? The router. Is there an IP address on that router for people in this VLAN? Yes. What is the address? Now say 192, 192, 192.168.1.1. That is what we put on the router. So when this guy needs to go out, it will pass through the router first. So the point I'm making is this: if your computer does not have a default gateway, he's just a local champion. He cannot go out of that network. He can't travel out of the country. He can only reside in that country, in that local area network. So I'll okay this. I'll go to the next one. So what do you have there? Go to desktop, ipconfig. You also belong to 1.0 network. I will remove the address there. 192.168.1.1. Everybody that are in that network, we have the same default gateway. Don't ever forget that. So I'll go to the next guy and say, okay, you two, there's good news for you. Good news in the house. Oh, you belong to 2.0 network. Ah, no problem. We've taken care of your problem too. You take 192.168.2.1. That is what we put on the router for this subnet. So don't forget that. The next one, you too, you can go out. There's good news. Take your default gateway 192.168.2.1. Okay, any other person left there? 3.0 network. That is admin people. We'll go there again. That is why I kept that .1. 192.168.3.1. Why did we get the 3.1 for? That is what we put on our router for these guys in admin department. So I will go to the last computer here. I am going to do that for all the computers on my network, guys. Everybody must hear the good news that they can now travel out of the country or go to another VLAN. So what about on the other side? Let's also take care of the guys on the other side and see. Let's take care of guys on the other side. This one is 2.1, 2.0 network. This is a 2.0 network as well. This is 1.0 network, so 1.1. This is 3.0 network. When you see the computer's IP address, you know the network they belong to. So we have taken care of IP addressing and subnetting. So that shouldn't be a problem for you guys. This guy is also 3.0 network. What's their gateway? This is 1.0 network. So now that I'm done with this, everybody from different VLANs should be able to talk to themselves. So let's try this. Let's go to somebody in VLAN. This guy should be in VLAN 10. Show us your IP address. IP config. Show us what you got. You are 192.168.1.2. Can you talk to somebody on the other side? So ping 192.168.2.2. Somebody is the 2.2 on the other side. Somebody is the 2.3. Let me confirm that. Since somebody is the 2.2 here. This guy is 2.2. He's in a different VLAN, HR. So can this guy talk to people, somebody in HR? Let's find out. You know, when you're watching movies, sometimes when there's some bad thing to happen, you'll be hearing doom, 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 doom. So that is my action movie sign now. This is not going to happen. It's not going to go. Somebody will say, but I thought you've done everything that we needed to do. Why is it not going? There's one more thing I did not do, and I deliberately left it out so that you people can take note of that. When we started this journey, I told you guys, this interface need to be trunked. because it's carrying VLAN 10, VLAN 20, VLAN 30. Even this one needs to be trunked. But the good news is this one is support trunking by default, but this one does not support trunking by default. So we've got to go to this interface here and make sure it is a trunk port. Take note, the connection between your switches must be trunked. The connection between the switch and the router that is doing inter-VLAN routing must also be trunked. If you forget that, your inter-VLAN routing is not going to work. So how do we do that? Let me show you first. You will see that there is no trunking between that port. The only trunking we have is between our switches. Please take note of these commands. You need to understand all these commands. Show interface trunk. The only trunk we have is on gigabit 0/1. We did that. I showed that you guys in the last class. Look at the only trunk we have. The port I'm using next is gigabit 0/2. There is no trunking on that port. So what do? I will just go to that port and turn that port to a trunk port. We are good to go. So let me go to that port. Interface G0/2. I will say switch port mode trunk. We did this in our last class. Switch port mode trunk. I will hit enter. The moment I hit enter, I'm done. All this being equal, we should be good to go now. And another thing why I like about this class is when I'm teaching practical. If things does not work, that becomes an opportunity for me to teach you guys troubleshooting. So you need to know how to troubleshoot if things are not working accordingly. How do we troubleshoot? And don't forget what is troubleshooting. You look for the trouble and shoot it. You look for the problem and fix it. Thank you, Rosemary. So now, let's test for connectivity. Since we have done this, people from different VLANs should be able to talk to themselves. If it's still not working, we now try to troubleshoot. But this time around, it should work because I've done the needful. Ta-da! This guy is a genius. Can you guys see? Somebody in HR is talking to somebody in admin. Let's try another department. Let's say there should be 3.2 somewhere. So it doesn't matter where you are. Let's go to the other switches on the other side. What's the IP address? Let's look for somebody's address here and try to cross to the other side. This person is 3.4. So let's try 3.4 from switch A. So it makes no difference where you are, or 3.4. This is called inter-VLAN routing. So unicast will no longer be an issue. Unicast will be allowed to go, but broadcast will never go. So we still enjoy our, our segmentation, as if we're using a router. So even if I have 50 departments, this one interface can take care of that. One physical connection, multiple logical connections. We take care of those VLAN routing. But if for any reason you don't want people from different VLAN to talk to themselves, then you don't need to do inter-VLAN routing. Don't bother doing inter-VLAN routing, just leave them like that. So this is the first part of this class. I'm going to give room for question now. Okay, somebody said I should not be pausing the video when they want to ask question. It also helps. So people should try to be responsible by not interfering. You know, once I unlock you guys, some people will unlock them, unmute themselves. People, there will be noise coming, and they are not asking question. So that's the reason why I don't give room for. I always pause my video before that so that they don't mess up the video. So that is the end of this first part of this journey. So I'm going to give room for question. Please, if you're not talking, mute yourself. Any question? I've unmuted you guys. Let me see your hand if you have a question. Let me see your hand if there is a question. Okay, no question. I can't see any hand. Yes, that means I did a great job. Okay, so can I conclude that there is no question? Okay, thumbs up if you are good with this. Thumbs up, guys, if you are good with this. If it is question, let me see your hand up. Okay, good. Thank you, Engineer Headed. Thank you, guys. So you need to know this, and I'm going to send a lab after this class. Do the lab. You see, I'm not pursuing you guys up and down like my regular student to do the labs, but you need to do the right thing. All right. Since we don't have question, please, in case you raise up your hand and I'm not saying you, just talk. You can just go ahead and unmute yourself and talk. Okay. All right, since we don't have any question, so let's take 10 minutes break and come back in the next 10 minutes. 10 minutes. Don't let me look for you guys, please. 10 minutes, 10 minutes, we should be back. What we have left is not more, so we can relax. So see you guys in after 10 minutes. So the last part of this training this evening is very simple as well. There's something I didn't do. I think I should just do that now. I forgot. I just remember now. So let me just, thank God I remember. Watch out now. We took management VLAN for the switches, so that's where we're picking IP addresses from for the switches. So this switch, I think we gave this switch 4.2. We gave this switch 4.3. If there's another switch on the network, 4.4, and so on and so forth. And these switches too, they also need a default gateway. Why? If you need to manage the switch from outside the network, I mean by, let's say we're on the internet or you're coming from remotely, if that switch doesn't have a default gateway, you cannot manage the switch from outside. So these switches that we configured in our last class, they don't have default gateway as well. Why do they need default gateway? In case I need to manage them remotely from outside, not within the organization. Within, I can use the IP addresses. If I want to come from outside, even though I'm using the IP address, if they don't have default gateway, I cannot access the switches. So I also need to create a default gateway address on this router for the switches. So I will go back to that router now and do that as well for this switch. So I'm going to go to that router. Say, okay, same interface that we're using physically. Interface gigabit 0/0/0 dots. I can't remember the VLAN we created for management. I think VLAN 40. Just look at it here. Management people are in VLAN 40. So I pick his interface in VLAN 40 on my router to route traffic for people in management VLAN. So I'm going to say encapsulation.1q40. That means that interface is routing for people in VLAN 40. And I'll put an IP address from that subnet. IP address 192.168.4.1. Then subnet mask 255.255.255.0. I'm done here. Then I'll go to my switch. I will say, okay, you know what? You guys have IP addresses, but you don't have some default gateway. So let's find out what the switch got. Show, what's that command? Let me show IP interface and see. Show IP interface brief. Will not give me the IP address. Okay, you give me the IP address of the switch. Look at it here. But I think I want to see it with subnet map. So let me go to show run. So I'm going to see what the switch got already. Look at what the switch got here. This switch has an IP address 4.2 with subnet map, but the switch doesn't have a default gateway. So this switch is not accessible from outside of the network. So I'm going to go to the switch and say, I have good news for you. Look at the command, I will put it. IP default gateway. IP default gateway 192.168.4.1. Enter, and I'm done. That means this switch also now has what is default gateway. If I go back to my showroom right now, you will see now that thing is done. Information is completed. The switch has an IP address. It has a subnet mask, and it also has a default gateway. Where is this default gateway? I've configured it on the router. I'll go to the second switch and do the same thing. So take note, guys, even if you have 200 switches on your network, they will all have the same default gateway because they have their own management VLAN. IP default gateway 192.168.4.1. Hit enter. I'm also done here. So if you want to verify, you can go and see it in showroom. Look at it here. The switch has an IP address 4.3. It has its own subnet mask. And now that switch also has a default gateway. Don't ever forget this. If your switch does not have a default gateway, it's not accessible from the internet or from outside of that area network. You can access that switch locally with its IP address. The moment you leave that LAN completely, you cannot access that switch. So please don't take note of this. But that's not what we want to do in the second part. We want to get rid of our router because we are assuming that the network we're dealing with has 100 VLANs. And they said we should not use a router, we should use a layer 3 switch. Not a problem. Let's get rid of the router. I'm bringing a layer 3 switch. Where is a layer 3 switch? A layer 3 switch are your, what is it called? 20, 3500 series switch. 3500 series switch. Look at them here. I have 30 and I have 3650. You can the switches. I'll bring the switch out. This is a multi-layer switch. So when you hear that word multi-layer, it's a layer 2 switch. It can work as a regular switch, and it's a layer 3 switch. It can work as a router. You are now the one to tell the switch what you want it to do. So for me, I want this switch to work as a router. So I want to use this switch to do inter-VLAN routing. So not a problem. I'll plug it to my layer 2 switch, regular layer 2 switch. Don't forget we're using port gigabit. I'll go to the switch. I can pick any port on this switch. Let's say 0/2 as well here. It makes no difference. Then I've done a physical connection between the two switches. Take note of something here, guys. This interface is trunked already. This one also must be trunked so that this link can be a trunk link. And you're going to see that automatically they will form trunking because of DTP that I discussed with you in the last class, dynamic trunking protocol. They will automatically form trunking because one hand has been trunked manually, the other hand supports trunking, whether it is dynamic desirable or dynamic auto, it will definitely trunk with it because this is about switches now, switch to switch. So they form trunking. So you need to be aware of that. So we'll wait for this thing to form trunk, to turn from red to green. And then we can continue our configuration. Now, why this red thing, blue thing, and green stuff? We're going to see in our next class. Because in our next class, we're going to be talking about spanning tree protocol. You're going to see how we can move or we can push the switches or these connections to move to this green stuff faster. Meaning they are now ready to pick traffic and send traffic. So don't forget that. Another thing you should be aware, the cable I use here is crossover cable. Why am I using crossover cable? Like devices. Switch to switch is crossover cable. Like devices to switch to switch is crossover cable. So don't forget, these are the details you need to be aware of. So this green thing is like taking forever. Let me wait for it. I hope we don't have any issue there. It's supposed to turn green. It is when it turns green that we can now receive, we can use that link to send message. But before it turns green, we can go ahead and do our configuration. So I'm going to go to this switch. This is our layer 3 switch. I'm going to go to the switch, my configuration on this switch. Oh, it must be powered on. Which switch did I carry? Oh, I carried 3650. Oh, that's the way that one works. I didn't know. I'm always using 3500. So let me look for the power cable. Where is the power cable here? Where is the power cable? I think this is the power. Okay, I think it's powered now. They want me to put that power cable. Interesting. So I will click the switch. I'll go to the switch. I want to use this switch. Now you see this switch is asking me a question. Will you like to enter the initial configuration dialog? Just like the way a router asks question. I'll say no, I don't want that. So you go to this switch. Let's name this switch as a layer 3 switch. Oh, sorry. Host. That's the host name. Layer 3 switch. So change the name of the switch. So what do I want to do, guys? I want to use this switch to carry VLAN traffic for VLAN 10, traffic for VLAN 20, traffic for VLAN 30, traffic for VLAN 40. That's what we did on the other side. So what is the difference between using a switch and using a router? When you are using a router, you first of all enter the physical interface where you have that connection. But when you are using a switch, you don't need to enter any physical interface. You just go straight into the logical interfaces. And how do we enter logical interfaces on the switch? Watch out. Interface, VLAN 10. That's the logical interface on this switch for VLAN 10. And for switch, guys, the VLAN ID or number must correspond. Must. Unlike a router where you can pick any sub-interface to represent a VLAN, for switch, it must be the same. So this is interface VLAN 10. It therefore means I want this interface to route for people in VLAN 10. So what is my gateway? The same thing we put on the router. IP address 192.168.1.1 spacebar 255.255.255.0. Hit enter and then you say no shop. Bam. I'm done. I'm done configuring this logical interface for people in VLAN 10. I will just enter that logical interface by that number, put an IP address, activate it. You see that the interface is quiet. Why is it quiet? I'm going to find out. I will do for VLAN 20 as well. Up arrow key, guys. Interface VLAN 20. That means this is the interface that will route for people in VLAN 20. IP address 192.168.2.1 spacebar 255.255.255.0. Say no shutdown. Silence again. This interface also is quiet. Not problem. I'm coming to fix that problem. I'll go to VLAN 30. That's a logical interface VLAN 30. To route for people in VLAN 30. IP address 192.168.3.1 spacebar 255.255.255.0. Enter. Say no shutdown. Then the last one, which is our management VLAN, interface VLAN 40, because that is for VLAN 40. Then I'll put an IP address for people in VLAN 40. What's their own default gateway? 192.168.4.1 spacebar 255.255.255.0. No shut. I didn't do anything different from, as regards to IP address, right? So look at what I'm trying to do. Do show history. What did I do? Look at all the things I did. Oh, this thing is messed up. I wanted to show you. I entered those VLAN interfaces. VLAN 10, VLAN 20, VLAN 30, VLAN 40. Let's go to show run and see. Show run and see what I did. In case I make mistake, don't forget. Configure verify. I enter into VLAN 10 interface. These are logical interface. I put an IP address, which will become default gateway to those people in VLAN 10. I enter VLAN 20. I put an IP address, which will become default gateway to people in VLAN 20. I enter VLAN 30. I put an IP address. That becomes default gateway to those guys in VLAN 30. I enter into VLAN 40. I put an IP address. That becomes the default gateway to VLAN people in VLAN 40, which is your switches. Is this thing going to work? I don't know yet. Let's find out. Is there a trunk? Show interface trunk. Oh, good. There is a trunking between this port. And this trunking was caused, this side is on auto. Don't forget, one side is on auto. The other side has been done manually. But the most important thing, we achieve trunking. And the both of them are in native VLAN 1, not a problem. I don't intend to change native VLAN now. So now that we have a trunk and this thing is working right now, will we be able to ping between the people on different VLAN? Not yet. Let's find out. Before you remember, we're pinging. But you see now we're not going to ping again. Let me try 2.2 first. We're not going to ping again. We removed the router, we brought in a switch. And by configuration, the switch is supposed to be able to do everything for us. But this is not going to work. I left two things out. One I forgot, the other one was deliberately. I'll show you a point. So I'm going to bring the two of them out. So now, guys, whenever you want to use layer 3 switch, whenever you want to use a layer 3 switch, first thing first, you must tell that switch that you are going to be working as a layer 3 switch. And the command is you say IP routing. Hit enter. Sorry, as global configuration. No. IP routing. I mean, I know you're a layer 2, I know you're a multi-layer switch, but I want you to work as a layer 3 switch. You first of all activate routing on that switch. If you forget that, your layer 3 switch is going to work as a regular layer 2 switch. IP or routing, very important. That's the first thing you must do on your switch. The second thing you must do on your switch, let me show you something, guys. Show IP interface brief. Look at all those VLANs that we put IP addresses inside. The sub interface, I mean, these virtual interfaces. VLAN 10, it has an IP address. It is manually done. And then the line protocol is done, guys. But I've told you this has to do with layer 1. The other side has to do with layer 2. It did not say administratively done. There is a difference between the two. When you see the interface administratively done, it simply means you have not issued no shutdown command. But when you have said no shutdown and the interface is still done, then there is fire on the mountain. Something is wrong somewhere. Now I go to VLAN 20. It has an IP address. The logical interface has an IP address. But that interface is done as well. The line protocol, which has to do with layer 2, is also done. Same thing with VLAN 30. Same thing with VLAN 40. Why this interface is done? Guys, listen to me. Whenever you want to use layer 3 switch for inter-VLAN routing, those logical interfaces you are using, VLAN 10, VLAN 20, VLAN 30, they must be created on that switch. If I say show VLAN right now, brief, you will not see VLAN 10, VLAN 20, VLAN 30, VLAN 40 on my switch. This is not to say we want to move port into this VLAN. Because we want to use this layer 3 switch for inter-VLAN routing, those VLANs that they are routing for must as well be created on this switch before we are able to use their logical interfaces. If those VLANs are not created, these logical interfaces will be done. Yeah, you know, watch out now. The moment I start creating those VLANs, before even naming the VLAN, let me just say VLAN 10 now. You know we have VLAN 10. The moment I hit enter right now, bam, you see that interface will come up. I'm not even giving name. I don't even need to give name. HR, I don't need to give name. I can go and say VLAN 20. Create VLAN 20. Bam. That interface will come up. I can go and create VLAN 30. Bam. That interface will come up. Then I can go and create VLAN 40. That interface will come up. So if you go now and do show interface brief, you see that those VLANs are now working properly. Anytime you are working with any interface, you must get two ops. What I mean by hop? Two ops. Look at the first op here. Look at the first op here. The first one has to do with layer 1. The second one has to do with layer 2. This one, you must have 1, 2. If one op is here and the other one is down, that interface is useless. It's not going to work for you. You must find a way to solve the problem. This has to do with layer 1. This has to do with layer 2. So now for VLAN 10, up, up. VLAN 20, up, up. VLAN 30, up, up. VLAN 40, up, up. How did we bring them up? We just created VLAN on that switch. So my point again, the interface, the logical interface on the switch, the virtual interfaces on the switch cannot help you for inter-VLAN routing if those VLANs are not created there. They cannot help you. The switch cannot do inter-VLAN routing for you if you do not activate IP routing. These two commands are key. IP routing, or these two steps are key. IP routing, and those VLANs must be created. Don't forget, we are not trying to connect computers to this switch now. I see some people in VLAN 10, VLAN. That's not the point now. The point is we want to use this switch to carry to do inter-VLAN routing. That switch must be created with those VLANs before we can make use of the logical interfaces on that switch. And all things being equal, if we're now to go back to go and ping different VLANs, you will see that we should be able to go to different VLANs. The switch we should be able to take us to different VLANs. Let's check it out. Fair for catch me. You want to disappoint me. Let me try somebody in 3.2. On the other, okay, I think it's on this switch right then before we cross border. Now we're using our switch to do inter-VLAN routing. By cross border, the other side, the switch is doing inter-VLAN routing. The same thing that the router is doing for us. Why are we losing the first ping before? It's because of address resolution protocol. Now that that's built the hub table, you won't lose ping. You won't lose any ping again. So don't forget this. I've taught you guys hub as well in this class. So these are the things you need to understand. So the skill you acquire in this class today, you must be able to use a router to do inter-VLAN routing. You must be able to use a switch to do inter-VLAN routing, a layer 3 switch. And all of these labs, I'm going to offload on you guys as soon as we are done with the class. This is key. This class. You must know VLAN like you know yourself. You must be able to do inter-VLAN routing. Very important with the router and with the switch or layer 3 switch. That is most important. So that is the end of this journey. Any question, guys? So I'm going to unmute you guys again. If you have questions, yeah, okay. Thank you for the thumbs up. I'm great. Cool. Thank you, guys. So if you have questions, let me see your hands. So there are almost 3 labs. Thank you. 3 labs. One is for router. One is for switch. I think one is troubleshooting. So you got to do. Okay, Pedro is asking for increase in font size. Sorry, I'm just saying this. What font size is for what? For the router, I think I did that. I increased the font size. Yes, you can shut down the sub-interface on the router on the stick. Good question. So please, if you have questions, raise up your hand and I'll give you the floor. Okay, so I don't think we have any question. I can't see any hand here. So